Welcome to the lecture series of numerical methods. Today we are going to discuss about Romberg's method. Consider I is equal to integral a to b y dx. Evaluate with the different subintervals h1, h2, etc. Then by trapezoidal rule evaluate and form h is equal to h by 2. Let h1 equal to h by 2 and h2 equal to h1 by 2, h3 equal to h2 by 2, h4 equal to h3 by 2, etc. That is dividing h into two parts. Dividing h into two parts, that is h by 2. The next step, dividing h into 4 parts, that is h by 2 into 2 parts, that is our h by 4. And dividing h into 8 parts, h by 4 into 2 parts, that is equal to h by 2, and so on. So after find out this, define I is equal to, that is interval between h and h by 2, I of h comma h by 2 equal to I of h by 2 plus 1 by 3 into I of h by 2 minus I of h, and I of h by 2 comma h by 4 equal to I of h by 4 plus 1 by 3 into I of h by 4 minus I of h by 2, and I of h by 4 comma h by 8 equal to I of h by 8 plus 1 by 3 into I of h by 8 minus I of h by 4. This method may continue till we get two successive values of i's are equal. The systematic refinement of the values of i's is called Romberg's method. So the thing which we have read now is called it as Romberg's method. So how to do problem under Romberg's method? What is Romberg's method? So first the given integration, whatever be the given in the question, that integration should be evaluated with the trapezoidal rule. First we have to integrate the given integral with the trapezoidal rule. How to use the trapezoidal rule? We have to form some method. The method is the h is nothing but difference between the x data, that in the sense the range. If for example if it is instead of a to b, if it is 0 to 1, okay, so this 0 to 1 can be divided by 2, 1 by 2, okay, that is h by 2. Likewise for each interval, that is first we have to form h is equal to h by 2, and then this h by 2 we can call it as h1, so the new h1. Okay, after this h1 can be divided by 2, that is h2, and h2 can be divided by 2, that is our h3, and etc. So using trapezoidal rule we have to form this and all first, and using this h is equal to h by 2 we can find the value of trapezoidal rule, the integration value we have to find out. Same manner for h2, that is h1 by 2, using trapezoidal rule we have to evaluate the integral value. Likewise h3 also. So first case we have to apply trapezoidal rule with intervals like h, h2, h3. After find out this, we have to define a formula. What is that? That is the Romberg's formula. I of h comma h by 2, that is equal to I of h by 2 plus 1 by 3 into I of h by 2 minus I of h. Likewise the next case, that is h by 2 and h by 4, then h by 4 and h by 8. For all these things we have to use the formula. This is called it as Romberg's method. So when we can stop the procedure? Okay, so when you are finding the values between I of h comma h by 2 and h by 2 comma h by 4, h by 4 comma h by 8, likewise when you are doing, when we are getting the two consecutive values are equal, we can stop the iteration. Okay, so that is what we have written here. This method may continue till we get two successive values of i's are equal. The systematic refinement of the values of i's is called Romberg's method. So when we can get the two successive values are equal, we can stop the iteration. So this method is called it as Romberg's method. So Romberg's method, we can't directly go for Romberg's method. Before applying the Romberg's method, we have to use trapezoidal rule. This is the general we are discussing. If suppose in the question it is mentioned using trapezoidal rule evaluate h1, h2, h3, after that using Romberg's method evaluate the integral. It may be like that, or otherwise after trapezoidal rule we have discussed Simpson's 1/3 rule also. So if the question mentioned using Simpson's 1/3 rule, find h by 2, h by 3, after that using Romberg's method means you have to go for like that also. Or otherwise in the same question using trapezoidal and using Simpson's 1/3 rule, find out the values of this. After that using Romberg's method we can evaluate the value of the given integration. Like that also they may ask. So using the previous result, that is trapezoidal rule, Simpson's 1/3 rule, we have to find out the previous values, that is h by 2, h by 3 and etc. After that only we are applying the Romberg's iteration method. So when we can stop the iteration, two successive values are equal, we can stop the iteration. So this method is called it as Romberg's method. Now we will see the problem. Look at this question. Compute the values of I is equal to integral dx by 1 plus x square by using trapezoidal rule with h is equal to 0.5, 0.25. Then obtain the better estimate by using Romberg method. So this is the question. So in this question they have mentioned by using trapezoidal rule with h is equal to 0.5 and 0.25. So first we have to use trapezoidal rule, find the values of h 0.5 and 0.25. Then we have to obtain the better estimate by using Romberg method. So likewise they will mention in the question itself. If it is Simpson's 1/3 rule means we have to go for Simpson's 1/3 rule. In the same question at the same time they may mention two rules also, trapezoidal as well as Simpson's 1/3 rule, then they can go for the Romberg's method. So Romberg method won't come separately, it will come with either trapezoidal or Simpson's or both the rule. Is it clear? So now we will see the problem, how to do the problem. Look at the solution. First we will take the given integration. Look at the solution. Given I is equal to, what is given? I is equal to integral dx by 1 plus x square. So dx by 1 plus x square. See, we know very well that except dx, what is in the question? That is our y. So we know very well that y is equal to 1 by 1 plus x square. Is it clear? So y is equal to 1 by x square. It's given in the question using trapezoidal rule with h is equal to 0.5. Okay, so first we have to apply h is equal to 0.5. Let h is equal to 0.5. Okay, so first we have to find out our x data and then corresponding y values. So x values are, okay, h is equal to 0.5. That means h is equal to 0. Then, is x data 0, 0.5 and 1. Likewise our y values are, substituting here y x is equal to 0, we can get the corresponding y value 1 and then 0.8 and the last value is 0.5. So using h is equal to 0.5, we got the x data and y data. So now by trapezoidal rule, what is our trapezoidal rule? Integral 0 to 1 dx by 1 plus x square equal to h by 2 by trapezoidal rule, h by 2 y0 plus yn. Here our y values are y0, y1 and y2. So n equal to 2. So our y0 plus yn, that is nothing but what? y2. Okay, y0 plus yn plus 2 into remaining values. Remaining value is only 1, that is 2y1. So h is equal to 0.5. So substituting all the values, 0.5 by 2, y0 is 1 plus y2 is 0.5 plus 2 into 0.8. So using calculator we can get the value as 0.775. Okay, this is our first interval value, that is h is equal to 0.5. So you can call this as I of h. Okay, this is our I of h. I of h is equal to 0.775. And next given in the question, what is given? H is equal to 0.25. So for h is equal to 0.25, okay, next given value h is equal to 0.25. For h is equal to 0.25, we have to find out our x and y data. Okay, x data 0, start with 0 and 0.25, then 0.5 0.75 and 1. Is it right? Then corresponding y values are, the corresponding y values are 1, 0.941 and 0.8, 0.64 and 0.5. By trapezoidal rule, integral 0 to 1 dx by 1 plus x square equal to, formula already we have written. So for this h by 2 into, here y values are y0, y1, y2, y3 and y4. So y0 plus y4, first value and the last value, plus 2 into remaining values. What are the remaining values? y1 plus y2 plus y3. Substituting all the values, we can get the next answer. Substituting all the values, we can get the final answer is 0.782. This is our I of h by 2. First value we have taken I of h, and the next interval value is I of h by 2. I of h by 2 is 0.782. In the question only given h is equal to 0.5 and 0.25. If suppose one more value is given, 0.25 by 2, 0.125, it is given, we have to go for the next interval, but in this question given only 0.5 and 0.25. So for 0.5 we got I of h is 0.775. For 0.25 we got I of h by 2 equal to 0.782. So after finding the value of I of h and I of h by 2, using Romberg's formula, we can write the formula I of h comma h by 2 equal to I of h by 2 plus 1 by 3, I of h by 2 minus I of h. Now substituting all the values, okay, I of h by 2 is 0.782, 0.782 plus 1 by 3 into 0.782 minus 0.775. This is our I of h value, first value. Okay, so using calculator we can get the answer as 0.784. Therefore, by Romberg's method, the given integration value, what is the given integration? Integral 0 to 1 dx by 1 plus x square equal to 0.784. So in this question, it's given h is equal to 0.5 and 0.25. That is the reason why 0.5 and 0.25. That is the reason why we have stopped the procedure up to this only. Okay, if suppose it is given one more point, that is h is equal to 0.125 is given, we have to go for I of h by 2 comma h by 4 also. Okay, so this is the problem under Romberg's method. So once again I will repeat the procedure how to do the problem. For the given integration, first we have to use trapezoidal rule to form the intervals h equal to h by 2 and h2 equal to h1 by 2 and h3 equal to h2 by 2, etc. And then after find out the intervals by using trapezoidal rule, we have to write the formula of Romberg's method formula and finding the value of the I intervals, that is the interval values. If the values are equal, two successive values are equal, we can stop the iteration. So this is the procedure of Romberg's method. So in this question, find the integration value, compute the value of I equal to dx by 1 plus x square by using trapezoidal rule. If suppose in the question trapezoidal rule as well as Simpson's 1 by 3 rule also will be given, if it is 8 mark or 10 mark, according to the mark the rules will be included. So trapezoidal rule with h is equal to 0.5, 0.25, then obtain the better estimate by using Romberg method. So Romberg method is always comes with some other rules, trapezoidal or Simpson's rule, it won't come alone. Okay, so I is equal to, we have to take the given interval, h is equal to 0.5. Using this we have to find out the x data and y data. Applying the trapezoidal rule, we are getting the first. In the question, the limit is actually 0 to 1. Okay, so the question is 0 to 1 dx by 1 plus x square. Likewise for the second interval, using trapezoidal rule, we have to find out the second interval value. After find out the first and second interval value, using the Romberg's formula, we have to write the formula. Substituting the values, we can get the first integration value. Okay, if suppose the interval is increased by the question, we have to do for the next interval also. So this is called it as Romberg's method. Okay, thank you for watching.